Let's solve this system of equations using elimination. So when we use elimination, or any method, we're going to try to find what x, y, and z will work in all three of these equations. So using elimination means that we're going to eliminate a variable from the equations and solve one at a time. So when I'm using elimination, what I'm looking for are things that are going to be easy to eliminate when I add or subtract the equations together. So when I look at the x's, those are not particularly easy to eliminate because there's no easy way for me to add, for example, equation 1 and equation 2 that would eliminate an x, or equation 2 and 3, or 1 and 3. There's no easy way to eliminate an x. When I look at the y's, it looks like it's going to be a little bit easier because at least I have 2 and 3 that have opposite signs. So those would be eliminated if I added those two together. And to get this third one in, or equation 1, I would just have to multiply by 2 to eliminate that. So y seems like a good option. With z, again, I have 3 different coefficients, so that will not be the easiest one to use for elimination. So in this example, y is going to be the easiest to use for elimination because we have at least 2 equations that have the same coefficient with opposite signs. So let's go ahead and begin. We're going to start with eliminating the y, and we're going to start with equations 2 and 3. So equations 2 and 3, I'm going to eliminate the y. So let me just write those down here. This is equation 2 as written, and then equation 3 as given. And we are just going to add these 2 equations together. So 2 plus 4 is 6. The y's, -1 plus 1, they're eliminated, as we expected. And 3z plus 2z is 5z. And when I add these together, I get 52. So now I have a new equation that only has 2 variables. In order to solve an equation with 2 variables, I'll need 2 equations. So I need to do this again and get another new equation that only has x and z. So I already used 2 and 3. Now I think I'm going to use 1 and 2. I'm going to use 1 and 2 because they have opposite signs. This opposite sign is a really helpful tool when we are eliminating. Now I notice if I add these 2 together, I can kind of plan ahead. 2 plus a -1 is not going to eliminate the y value. So I need to multiply this equation 2 by a 2 so that it matches but has an opposite sign. So I'm going to do equations 1 and 2, but I'm going to multiply equation 2 by 2 so that it will be eliminated. Let's see what that gives us. Equation 1 is given as this. Oh, it's blurred a little bit there, sorry. And then equation 2, I'm going to go ahead and multiply everything times 2 so that I'll be able to eliminate. So that will give me 4x, and then a minus 2y. I'm just multiplying everything by 2. Then I'll have plus 6z, and that's going to equal 62. So now I can add those together. I have 5x, then I have 2y minus 2y, which is eliminated. Negative z plus 6z is plus 5z, and I know you can't see this, but over here I have negative 7 plus 62, which will give me 55. So now I have 2 equations with 2 unknowns. I can use elimination to eliminate one of those. So when I look at these, the first equation, my first new equation, is 6x plus 5z equals 52. Then I have 5x plus 5z equals 55. So those are my new 2 equations I'm going to look at. When I look to see what I can eliminate, the thing that jumps out to me is that they both have a 5z. That means if I subtract these equations, the z term will be eliminated. So I'm going to subtract, and I'll just write this new number 2 over here. I'm going to subtract it from number 1. That will give me 5x plus 5z equals 55. And I'm going to subtract the 2. So 6 minus 5x will just give me 1x. Then I have the 5z minus 5z. The z's are gone. Now I have 52 minus 55. And I have found that my x value is -3. So that's my first solution I have found. Now I'm going to work backwards and substitute this value in to find my y and z. So let's start with finding z. I'm going to start with finding z because that's what I have these two equations set for. So now that I know what x is, I can plug it in. So let's see, where can I do that? Let's come up here. So I'm going to plug in x to be -3, and this will be my equation 1. So if I have 6x, which will be -3, plus 5z will equal 52. Now I'm going to solve that for z. So that's going to give me -18 plus 5z equals 52. I can add 18 to both sides, and that will give me 5z equals 70. Now if I divide both sides by 5, I'll get z equals, let's see, 5 goes into 7 one time and 20, 14. So I have z equals 14. That's my second solution. So now I just need to find y. Well, I can go back to any of my first initial equations to try to find y, whichever one I like. So I think I like maybe just equation number 1. That's fine. So I'll use equation number 1 and find out what y is. So equation number 1 says x, which we found to be -3, plus 2y, we don't know y yet, and minus z, which we found to be 14, is -7. So I have -3 minus 14, that's a -17 plus 2y equals -7. I can add 17 to both sides, and I get 2y equals 10. Coming right here, I'm going to divide, so I had 2y equals 10. I'll divide both sides by 2, and I find that y equals 5. So now I have all three solutions. The solution to this system of equations is x is -3, y is 5, and z is 14. And we've solved that using elimination.